Okay, grade 12s, let's look at some further examples on quadratic number patterns. Have a look at this one. I'm going to give you this pattern 6, 13, 22, and 33. And what I want you to do, there's two things. We're going to be working out the nth term, or the general term as usual. But then here's something new. I want you to determine which term is equaling, which term equals 118. Okay, very interesting. Now, let's get the general term of this number pattern. So number A, we've got here 6, 13, 22, and 33. Now let's get the constant second difference. Well, 13 minus 6 gives you 7, 22 minus 13 is 9, and 33 minus 22 is 11. And so we get a constant second difference there. And then how do we generate our A, B, and C? 2A, 3A plus B, and A plus B plus C. Okay, so what is 2A equal to? 2A is equal to 2, so then A is equal to 1. Okay, now what's 3A plus B equal to? Is 7. A is equal to 1. So there we go. So that's 3 plus B is 7, and B is then 7 minus 3, which is 4. And then we've got A plus B plus C is going to equal 6, because that's your first term there, which it's now connecting there nicely. We already know what A is. A is 1, B is 4, and we can then easily work out what C is. So C will be 6 minus the 5, which is 1. So what's your general term? Is an squared, which is 1n squared plus 4n plus 1. That's A, B, and C. Look at that there. There's A, B, and C. Okay, so then Tn would be n squared plus 4n plus 1. Now, I want you to watch this B part. It says which term equals 118. Now listen to me carefully in the B part. If I look at the sequence, I've got 6, 13, 22, and 33. If I said to you, which term, now look at this, which term is 13? You would say that it is the second term. In other words, the n value for the term is 2. This is the second position. It's term 2. The n is 2. So if I said to you, another way of looking at that could say, which term is 13? You could say term with an unknown position is 13. And what is the n? Well, you can see it's clearly 2 there. Okay, so the idea is to get n. If you say which term is 13, the n is 2. You can see it there. So the idea is to get n. So when you want, if I said to you, so which term is 118? Well, how on earth are we going to get the n? Well, what have we got? We've got the formula for Tn, which is going to be, this is going to be n squared plus 4n plus 1, and let's equal 118. Okay, now if you bring that across, you've got 1 minus 118, and we into trinomials. Look at this. So it's going to be minus, if you look at that, 117 is equal to 0. Now that's quite tricky, so you could use the quadratic formula, or if you want to use the grade 11 method, okay, you could do this as well. You could say, well, what about 117? Now, interestingly enough, 9 times 13, that would be tricky. 9 times 13 gives you 117. Okay, and then, of course, we could say that's going to be minus 9 plus 13 will give you 4. 13 minus 9 is 4. So then n is equal to 9, or n equals negative 13. But hang on. But n cannot equal negative 13. You can't have a negative number of terms. You can't say, what is the negative 13th term? That doesn't work. So there must be 9 terms. So the 9th term there would be equal to 118, the 9th term. Okay, so if you expand there, and by the way, you can of course use the quadratic formula if you like. If you look at this to solve that, n squared plus 4n minus 117 is 0. What you do is you say n is equal to, remember that's A, B, and C. So you'd use this formula. Minus B is plus minus the square root of B squared minus 4AC all over 2A, like you did in the previous lessons when we revised the quadratics. And then you can use it. You could say n is equal to minus 4 plus minus the square root of B squared minus 4AC. Okay, all over 2A. Okay, and then you could work that out as well. You could say that's negative 4 plus minus the square root of something over 2. So let's use a calculator. What's that? That's 4 squared is 16. A minus and a minus is a plus. And then 4 times 117 will give you 484. So if we look at that, 484. Okay, and what does that give us there? 484. We can put that into there. And then if you square root that, you get negative 4 plus minus 22 all over 2. And then n will be equal to minus 4 plus 22 over 2. Or if you like, or n would be equal to minus 4 minus 22 over 2. Okay, so let's just see what that would come to. Well, 22 minus 4 is 18 over 2, which of course is 9, which is what we want. Or n could be minus 26 over 2, which is going to give you negative 13, and that's what you don't want. Okay, so in other words, we're going to scrap that. Okay, so you could use the quadratic formula as well if you so wish. Okay, but otherwise you can just factorize as normal. So watch out for these questions. They come up quite a lot in exams and that. Okay, now I want to show you another example, which is a classical exam question. Have a look at this one. Guys, they do this often in matric. They'll give you this quadratic pattern 1, 7, x, and 31. And they want you to calculate the value of x or determine it. They say that this is a quadratic. So it's given as a quadratic pattern. Find the value of x. Now this seems quite a bit tricky. Now watch this. It's not so bad. If you do exactly what we did in the past, have a look at this. Well, we can get the first difference row. 7 minus 1 is 6. This here would be x minus 7, and this would be 31 minus x. Okay, now you do it again. Now watch here, and we get the constant second difference. So this will be x minus 7 minus the 6, and this here would be 31 minus x. Subtract the x minus 7. So what does this come to? That's x minus 13. This one would be 31 minus x plus 7. So we've got 38 minus 2x for this one here. But remember, in the second difference row, you get a constant second difference. So in fact, those are equal to each other. So we've got x minus 13 is 38 minus 2x. And all we got to do is solve for x. So let's bring that across. So negative 2x goes across, becomes plus 2x, and we've got 38 plus 13. So that's 3x is equal to, what would that come to? If you think about it carefully, that's going to come to 51, because that's 38 plus 13. And if you divide both sides by 3, you get x is equal to 17, should I say. Okay, let's just redo that quickly so it's correct. It should be 17. There we go. Now have a look at that. If we put 17 back, we've got 1, 7, 17, and 31. Now let's see, is it quadratic? 6, 10, 14, 31 minus 17 is 14, and there's a constant second difference. Look at that. There we go. And of course you could now generate your little general term if you wanted to. So 2a is equal to 4, so a is equal to 2, and what's 3a plus b equal to? It's equal to 6, and what do we know? We know what a is already, so that gives us 6 there, so that's 6. So b is equal to 0, because it's 6 plus b is 6, so b is equal to 0, and then we've got a plus b plus c. I love these things. A plus b plus c is over here, is equal to the 1 there. So we can say it's 1. We know a, we know b, so we can work out what the c is. C is 1 minus 2, which is negative 1. So then Tn is an squared plus bn plus c, which gives you then the 2n squared minus 1. And there's your general term.